This is lecture 19, example 1. So this is going to be our first example using interrupt-driven program. So these examples are very simple. And the issue is that, we use interrupts to avoid polling, yet, these examples have polling. Now, the only excuse I can make there is like the programs are really simple. It's okay to poll when you don't have anything better to do. So these programs, essentially, when they have something better to do, when they get an interrupt, and it does that, otherwise it goes back to a poll. Now, inside the poll, if you had other better things to do, you could go deal with them. But for these programs, it's just they are kind of chunky looking. Now, keep in mind, this is what we're going to have here is this external pin here on the microcontroller, the RISC-V. Now, some external device is going to connect a signal to that pin, and when it needs some type of help or service, it's going to assert that signal. And if the interrupts are unmasked on the microcontroller, if they're enabled, it's going to go in an interrupt cycle and execute the interrupt service routine and does do what it needs to do. And so these are fairly simple problems to work on here. I'm actually going to try something new in this one and try to bring over the we'll see if it works. I'm trying to bring over the flow chart for this thing. So once again, let me go ahead and start with a flow chart and then bring it over, hopefully bring the flow chart over to the assembler. So let's go ahead and do this. I'm going to try to keep it not too big here. So that's going to be my program. So this is initial, and you need to essentially look at the example program to get going on this. I mean, generally when I write these, I cut and paste them. It's not a big deal. Essentially, the setup and the initialization is typically always very similar. Okay, so what we have here is a problem it's just every time it gets an interrupt, it advances a counter. So when that counter is less than 28, let's see what it says here. Oh, it turns less than 28. It turns on the rightmost LED. So remember, this is a counter that's counting 0 to 255. When the count is less than 28, the rightmost LED is turned on. Okay, so let's go ahead and do that. And so these programs typically have init stuff. First thing I'm going to do here is initialize the interrupt, and to probably initialize a counter, and initialize I need to probably use a flag variable just like the examples, and I should have put that in there. And then I'm going to enable the interrupts. Okay, so after I enable the interrupts, I can go into my unfortunately my poll here, and I think I'm going to use is flag 0, and I'll say yes. Otherwise, it'll be a no. If the flag is 0, what I'm going to do here is increment the count, and then I need to, I'll just say output. I need to do something special to it. Output LED value, and that looks good. And last thing I want to do here is clear flag, and we'll do one more thing, enable interrupts, and then I can go back up here. Okay, so once again, increment the count, output the stuff. This is going to be special because I got to deal with it. I'm going to clear my little flag, and then I'm going to enable interrupt. So what I have up here is an ISR, and I'm going to set flag, and then I am going to return, and I'll put an M return in there just because. And okay, and that's it. And what I want to do is implement this in code. So let's go ahead and try to do that. I'm going to switch over to RARs, see if that works. Let's do it. Okay, so I'm using the RARs assembler, and hopefully you'll be able to see this. If not, I'll re-record it somewhere else. Nice thing here is that the Venus doesn't recognize the control and status register, so it's pretty useless when you're using interrupt. So what I've done here, hopefully, is I've chopped the flowchart that we made out, and I'm going to work off that. Now I'm also sitting in front of me is the original example from the book, and I'm going to work off that too, because lots of times the syntax, I know what to do, but I just don't know the syntax. So, okay, so let's do this thing. This is just, we'll call it program, and we'll call it a knit code. And so the knit code is initialize the interrupts. I think before I do that, I want to initialize the output. So we got to write the LEDs. So that's a load immediate. I don't know what you want to put here. X30. 0x1100 C0000. Okay, looks good. Okay, so now I'm here. I'll put a comment. Output address. Okay, so next is I want to initialize the interrupt. So the very first thing says initialize interrupt. Essentially, I need to get the location of the interrupt service routine, which just for kicks, I'm going to go ahead and put down there. And we'll go back and fill that in later. And so what I want to do here is load address of the interrupt service routine into a register. Okay, get address, and I want to store that in one of the CSR registers, which is empty vec register. So what I'm going to do is CSRRW, and it doesn't matter what I write for this. I'm not going to use it. That register is this instruction actually reads the register and puts it in X0, which is I'm not going to use it. At the same time as it writes a new value to the register. So this is empty VEC. And what I'm going to put to is X6. So this instruction is storing the vector address of which is the address of interrupt service routine. Okay, that looks good. And what else we got here? Interrupt counter. Let's make a counter. I don't know where you want to move it. I don't know. How about X20? X20, X0. Here's clear the counter. And what else do we need to do here? A flag. I like using X8 because it's similar to my other routine here. X8, X0, clear flag. And what else do I need to do? I think I need to put the interrupts or the counter in. Essentially, I need to turn off the LEDs, and I should have put that in there, but I forgot. So let's do that. So that's going to be a store word, and X20 is my counter, which is 0 because I cleared it. 0. X30 is I stored my my output address, the LEDs up above. Check it out. That's too long now that I'm looking at it. Okay, and this one is going to be turn off LEDs. Okay, and I think that's it for that. Last thing I need to do is I'm at this state right here, which is enabled interrupts. So once again, I'm gonna load immediate x10, just a value of 1, and that's what I'm going to do here is enable interrupts, and so that's going to be another CSRR instruction. So I'll just go copy this because I'm lazy, and this is going to go to MIE X10. Okay, and we don't really need that comment. Okay, well, I think I'm ready to go on that one, and I think next thing I want to do down here is write the interrupt service routine, which is going to be essentially if it gets an interrupt service routine, it's going to load something in X8, I'll just do 1, and then return. Okay, so there's our whole interrupt service routine right there. Not too fancy. And we got a ton of space here. So this is going to be the main loop here. So I'm going to call it main. And I like it in the leftmost column. And I'm going to say, what I'm going to do here is put instruction jump. No, B, E, Q, branch X8. As long as X8 is equal to 0, I'm going to jump to loop. Okay, so loop, and this is loop. Okay, so this is the polling loop that's looking for the fact that the flag got set. The only way the flag is going to get set is if it gets an interrupt, and and it executes this code here. This code here puts a 1 in X8. Originally, I turned the X8 off up here, so let's do that. Loop. This is going to be I don't know if that's the best name, but good enough. Okay, so if it breaks out of this loop, then that's what I need to come over here. So that's this loop right here. This is this right here. So what I need to do over here is increment my count, X, and the count is in X20. One. Increment count. Okay, and so at that point I need to output the LED. So this one is somewhat tricky on this one. So what I'm gonna do on this thing is output the bit, the 2 to the 7th bit, which is the 7th bit, 0-based bit, but I'm going to toggle it first. So we want this LED to be on when it's less than 128, and so I'm just going to go ahead and output that bit as is. So what I'm going to do here is a couple things. I think I'm going to I think I'm going to clear this, and I don't think I need to do that, but I'm gonna say I need to do that. Mask count. So the count may have grown greater than 8 bits, but I'm going to keep it at 8 bits. So the issue here is I'm going to what am I going to do? I'm going to mask. I got to get that 1 bit, so I need to mask it. So I'm going to do another masking operation, and I'm going to store it somewhere else. X20 0x80. Okay, so this is going to be mask the bit 7. Okay, so I've masked bit 7, so that means I know what it is, and if that bit's a 0, then I want to turn the LED on. Okay, so that means I'm going to, and it's going to be the LED in the LSB position, so I'm going to do two things to it. First, I'm going to, what am I going to do to it? Shift it right, shift right, logical, immediate, X21, X21. I gotta figure that out. 7 times on a piece of paper to get this right. 1, 2, 3, 4, 5, 6, 7. It actually shifts 7 times. Okay, so shift right, RIGHT 7 times. Now I have it in the least significant bit position, but what I want to do is exclusive OR it, immediate X21 with 1. So that toggles it. So remember, if that bit's a 0, I want the LED on, because that bit's a 0. That means the count is 127 or less. Okay, so let's do that. Toggle, and then I'm ready to output it, and we can output this SW. Heck, why bother? Cut and paste, X21. There it is. And life's good. And so that's the output LED command there. What I need to do now is get rid of this junk here. Go away. What I need to do here is clear the flag. So let's move X8, X0. Go ahead and just clear flag. And then I need to re-enable the interrupt. So like I got this up here. I'm going to cut and paste it. And cut and paste it. Where did my interrupts go? Okay, and then I'm going to return to my polling loop. Return to polling loop. And then, hey, let's put some comments in here. Make this really good. And this is going to be, what am I doing here? Set flag to non-zero. And this is going to be return from interrupt. And I think I'm going to call this done. Just because I can, I'm going to go ahead and compile this, which I know is an F3, so I'm pressing F3, and it because it went over here, I know it compiled, and this is you can see the addresses here in the machine code. And for that, I'm going to call this done, and I'm just hoping that this actually is something you can see on the on YouTube. Let's hope for the best.